welcome to the third session in module 2. So we were discussing object oriented modeling as part of the module 2 syllabus. In the last two sessions we had seen a basic introduction of the syllabus with respect to what is there in module 2. Also we understood a few basic aspects of object oriented modeling. Just to summarize so that we can get a continuity with respect to this particular third session. So we'll have a recap or overview of what we had discussed in the previous session. So first we understood the importance of design. Okay, we understood why design is a very crucial stage, a very important stage in developing a software. So that was the first point. We also understood the best way of doing the design. Okay, so that is object oriented design. So object oriented design has many powerful features, has scalability, has flexibility, because of which we have adapted object oriented design. Okay, so we had gone into that with sufficient detailing in the previous session. Next we understood few object oriented characteristics. So what are the different characteristics of object oriented modeling, object oriented design? So that was discussed in the previous session. So we understood what is a class, we understood what is an object, we also understood how subclasses can be created and how these subclasses can help us, can benefit us through by reducing the size of the code. Okay, so all these things were discussed in the previous session. Next we will start with abstraction in today's session. This is one of the major themes of object oriented programming. Okay, so major theme of object oriented modeling, object oriented design is abstraction. What exactly is abstraction? See, abstraction is an English word, so it means that hiding. Okay, hiding the details. Now what is the benefit of hiding the details in maybe a design or implementation? See, the major benefit here is you can cover the complexity, okay, with respect to the stakeholder. Okay, so the person who is visualizing the design or maybe the implementation, so if you want to hide the complexity from that particular viewer, so abstraction can help us. One more major benefit of abstraction is hiding the data. Okay, which is not relevant, which is not necessary for demonstration purpose, maybe to the designer, to the stakeholder, or to the developer. Okay, so we can even hide the data also. Now how this can be achieved, how abstraction can be achieved? So we have a mechanism in object oriented modeling. So that is, for example, we will consider a class, some class ABC. As already discussed in the previous session, a class will have two sections. One is attribute or properties. So the other section is the functions or actions. Now consider I have few values within this class ABC. For example, I have this A equal to 2, B equal to 5, C is equal to 3. This example is just for demonstration purpose. Three variables are there, A, B, C. Now assume that I do not want to show A equal to 2 to the stakeholder. Okay, I do not want this to be visible outside. Let B is equal to 5 and C is equal to 3, let it be visible. Okay, so this is one way of planning our abstraction, and this can be done by using a mechanism available called as private. So within the attribute section we can have something called as a private space, and whatever data you are putting into the private space will not be visible outside, meaning that you are hiding the data, you are hiding the details. Okay, see, this data may be a data which may not be needed to the stakeholder. Also, maybe you want to make this data secure, you do not want this data to be visible outside. Okay, in that case you can do this. So the other parts of the data that you want to be visible, okay, you can make it public. So we have a very powerful access specifier mechanism wherein which you can ensure the data is hidden, data is secure, unwanted data is not visible to the stakeholder through a feature through using private and public access specifiers. Okay. So all these are part and parcel of abstraction. Okay. So next one is encapsulation. Okay. So what exactly is encapsulation? So as you can see, encapsulate. Okay. Once again, we are wrapping the data. Data is being wrapped. So we are wrapping the data so that the data is secure. So this is one more very powerful feature in object-oriented designing. Okay. So we can ensure the data is secure by wrapping the data. Okay. Now, if we wrap the data, then how the functions can access the data? Because already I had discussed in the previous session. You consider any class. Okay. Take any class, for example, class A. Data is there here, x equal to 3, y is equal to 4. Function is there here. Okay, so this is the attribute part, this is the function part. This function should be able to access the data. Okay, it should be able to access the data, then only we can get the desired result. Okay, for example, add function should be able to access x equal to 3, y is equal to 4. Maybe it will add these two numbers and give us the desired result. But if you are encapsulating this, okay, if you are encapsulating this, now how I can ensure this function can access this data? Okay, so encapsulation is basically hiding. You are hiding the data here from the functions. Okay, now if you do this, how exactly a function can access this data? Okay. So encapsulation ensures wrapping takes place in such a way that data with function, is wrapped in a secure way. Okay. See, the function can access the data only within this specified secure area. Okay. Process it, manipulate it, then return the results back to the calling point. That's it. Okay. To be more clear, I will take a very specific example through which we can improve our understanding with respect to what is encapsulation and how exactly our data is being secured, how it is being wrapped to ensure that outside functions do not access it. Okay. So we will consider an example. For example, class internals. We have a class internals. So this class internals has two sections as discussed. One is the attribute. Okay. We will consider different marks. For example, marks S1 is equal to maybe 15. Okay. So marks in 3 subjects scored by a specific student, S1, S2, S3. Okay, so that is class internals. Okay. So as we are aware, we can create hundreds of objects for a class. For example, for this class internals, so I have my class internals, I can create hundreds of objects. For example, I will create an object by name Anil. Okay. So Anil object has been created for the class internals. Okay. Now what happens when Anil object is created? So as per the default mechanism, as per the default design, okay, so whatever attributes and functions are there in the class can be taken by this Anil object. Okay. So please note, Anil is an object here. So whatever attributes are there, whatever functions are there, so it can be taken by the Anil object. Okay. For example, compute is the function here. It may be within the class, or also maybe it may be outside. But our plan, our design plan is, this should not be accessible. This should not be accessible to Anil object. Okay, can we do this? Can we have this design? Object that is created for a class should not be able to access the data, but still it should be able to process it. For example, Anil object should be able to use the compute function, okay, maybe to compute the average of S1, S2, S3, but without accessing this. Okay, without accessing S1, S2, S3, Anil object should be able to obtain the average through compute function. Is it possible? Okay, so now encapsulation mechanisms comes to our aid here. So we can do this through encapsulation. What is the reason? So encapsulation provides us with a feature wherein which the data and function is binded together. For example, in this case, so S1, S2, S3 and compute. So please note, in this specific instance, this is the binding that you can see. Okay. So this is a binding you can see where the data, that is S1, S2, S3 is encapsulated with the function. It is binded, it is secure. See, in this secure region, in this binding region, the Anil object cannot reach, it cannot access this. Now what is the benefit of this? So Anil object cannot read S1, S2, S3. Now can the compute method that is part of Anil object access this? Yes, definitely. So the compute method that is part of Anil object can access this, that is, it can perform the computation, that is average of S1, S2, S3. So it can do this. So S1 plus S2 plus S3 by 3, which is the computation done by the compute method. Once done with the result, for example, you consider 13.3 is the answer that is obtained. Okay. Now the compute method will return back 13.3 to the Anil object. Okay. Now did we serve the purpose or our design plan? Okay. Is it served? Yes, definitely. See, what was the requirement here? The requirement was the Anil object, that is an object of class internal, should not access S1, S2, S3. It should not be able to read this. Okay. Anil object should not read the marks directly. Anil should not get to know what was his marks in S1, what was his marks in S2, what was his marks in S3. This thing should not be known to Anil. But still, Anil should be able to compute the average of the 3 marks. Okay, he should get the average. That's it. He should not get to know the individual marks S1, S2, S3. So this design is supported through what is called as encapsulation, where the data part and the function part is encapsulated, is binded securely. Okay. So the compute method within Anil object can access S1, S2, S3, do the required computation, get the result and pass the result back to the Anil object. Now what Anil will be able to access now? See, Anil will be able to see his final average 13.3. He will be able to see this, the Anil object. But Anil object will not be able to see S1, S2 and S3. This is not accessible. But the final average of S1, S2, S3 is accessible to Anil. So this was one simple mechanism which gives a picture of what is encapsulation and how exactly encapsulation can be planned, can be designed using object-oriented modeling. Okay, and what are the obvious benefits of it, how it can benefit. So this example was a demonstration of this. So the bottom line here is an object for a class need not access the data members, but still it can do the required computations. Ultimately we are making our data secure. Okay, we are making the data secure from the objects belonging to that specific class. Okay, so models in O modeling. Okay, and in the previous discussions we saw that object oriented modeling is basically design. That's it, it is design. We are not doing any hard coding here. Okay, so we are not generating any implementation details, but we are just coming out with a plan. That's it. Okay, that is object oriented modeling. Now once you are done with the design plan, you need to represent it. Okay, how you can represent the design? So that is what you are studying in the models in object oriented modeling, and there are three popular models. Okay, three types of models, not limited to three, many are there, but the ones which are very much popular are the first one is the class model. Okay, so what is a class model? So this was demonstrated in the previous session. Once you identify the real world entities in the client requirement, we create a class. Okay, for example, I had taken the patient monitoring system. In the patient monitoring system, the real world objects were, so doctor, patient, okay, maybe vehicles, medicines. Once done with this, once you identify the real world entities, we created the class. For example, class person. We created this class person. Also, for a class we created subclasses. For example, this person can be a doctor, class doctor. Okay, so it can belong to class person. So we saw this through the inheritance relation that we had explored in the previous session. Also class patient. So class patient, he can also belong to class person. So class person is the main class or super class. So class doctor and class patient is a subclass. Now what exactly we are doing in class modeling? So this is what we do. So we try to identify classes from the real world entities. Okay, so these are the real world entities. So from the real world entities, we try to identify the class and even subclass. Not only identifying the class and subclass, we try to build the relationship between them. For example, maybe how class doctor, how it is related to class patient. Okay, so we represent that through lines. Also mark the relation. Many types of relationships are there, the detailing of which we will see later. Okay, the bottom line here is the class model helps us identify the different classes, subclasses, and how the classes and subclasses are related to one another. Okay, so this is the class model. Please note, basically the focus is on the classes and how the classes or subclasses are related to one another. That is class model. It's a static model. Okay, it does not demonstrate how exactly the classes are interacting at different points of time. Given an input, how the class state changes from maybe one state to another state, all these things are not depicted. So it's a static model. So class model is a static model. So the next model, which is the state model. Second way of representing the O modeling. Okay. Just now we saw the first way, the most popular way of representing object oriented design or modeling, that was using the class model, where the emphasis was on classes, subclasses, and how they are related with one another. The second way of doing it is the state model. What is a state model? So basically this model depicts how objects change over a period of time. For example, at a time t1, okay, so object was in state 1. Maybe because of interrupt or because of an event, maybe at a time t2, the same object went into a different state, okay, state 2. I'll mark it as state 2. Okay. So at different time periods, the object is entering into different states. Okay. So this is depicted using the state model. So one of the examples for state model, I'll take an example of a doctor object. Okay. I'll consider a doctor object. Now, a doctor object that is created within the patient monitoring system or patient monitoring software can be in different states. What are the possible states in which a doctor object can be found? Okay. So this is the starting point. Now we will assume a doctor has been newly appointed in that specific hospital. So now the doctor object will be in the registration state. Okay, a new doctor has been appointed. Maybe he would register his details. Okay, he is registering his details. So the doctor object is in one state. We will call it as state 1. State 1. State 1 of doctor object in this example is he is registering his details. How he is doing it? Maybe he is using some functions like add details. So he is providing his information to the hospital, like his name, his previous experience, his identity, PAN card. So all those details he is providing to the hospital management. Okay. This is state 1. Now once we are completed with the registration, so the newly appointed doctor has completed giving information to the hospital system, hospital management. Now he will be allocated with the patient. Okay, so patients will be sent to him for diagnosis. Okay, so because of patients, the doctor object now maybe will enter into a different state. Okay, now in this state, what the doctor object is doing? Okay, so he is checking the patient. Please note the difference. The object is same. The object is doctor object. Okay, but in this state, the doctor object was busy doing registration, but here the doctor object is busy checking the patients. Okay, what he may be doing? Maybe he is diagnosing. Okay. He is doing some tests on the patient. Okay. Now once done with checking the health status of the patient, we will call it as state 2. Okay, now it is state 2. Once done with this, the doctor object can enter into maybe a different state. I will call it as state 3, where the doctor object is updating the medical records. Okay, so the medical records of whom? The patients whom he has checked or verified, he may be updating it. The same doctor object, once again please note, the same doctor object is updating the medical records of the patient. Okay. Now it is state 3. So in this design we are basically focusing on representing what are the different states of the objects because of different triggers or because of a change in the scenario, okay, to which state it has entered. So that is state model, the second most popular object oriented modeling. So the third one, the third modeling, so third modeling technique is the interaction model. So interaction model, please note the second one that was just now discussed was a dynamic model, it is not static. The same carries to the third one, the interaction model is also a dynamic model. Okay. Now how the objects are interacting with one another at different points of time. So starting from the beginning, this initiation of the system maybe to the end of the system. Okay. From the starting point to the end point, how the various objects are interacting, how the entities in the systems are interacting, how they are moving from one state to another state. So all these things will be combined in interaction model. Okay. Now what are the different ways in which you can represent an interaction model? So interaction model is usually popularly represented using what is called as a use case model. So use case model is a type of interaction model where emphasis is given on the users of the system. Okay. So we have a system in place, we have the software or system. Okay. So how the different entities related to this software or system will interact with this, will use this. So with that emphasis, use case modeling will be represented. For more clarity, I will take an example. For example, consider this is a patient monitoring system, okay, or the hospital management software. Hospital management software or patient monitoring system, whatever it is. Okay. Who are the different actors who are involved with this system? So as we had already discussed previously, it may be a patient. Okay. So it may be a doctor. Okay. It may be maybe a manager, receptionist. So these are the different entities who are interacting with this system, patient monitoring system. So we have a notation for this in use case model. We use a human stick-like figure. Now how they are interacting is also represented. For example, how patient will interact with this hospital management software, how he can interact, what the patient can do. The very first thing is he need to book an appointment. See, he cannot directly visit the hospital. There are few standard procedures and protocols. First, he should book an appointment with the system. Okay. So a receptionist will verify the appointment. Receptionist will check the availability of the doctor and then confirm the appointment. Now patient will visit the hospital, he will get the required tests and diagnosis, and once done with this, he need to pay the bill. Okay. So bill payment. So as we can see, how the patient entity is interacting with this software, with this patient monitoring system. So only two major ones I have represented. Still we can have many types of interactions. Just as an example, I am just giving you few instances. Okay. Now with a doctor, how a doctor can interact with the system, what he can do. Okay. So a patient comes to the doctor. So as we are aware, he can do the required diagnosis. Okay, this is what a patient can do, a doctor can do. Also, after doing the diagnosis, he can give the required treatment. So please note, use case model is a type of interaction model which is giving a design description of how the different entities or actors involved with the system are interacting with it. Okay. For example, patient is interacting with the system through booking the appointment, generating the bill. A doctor is interacting through diagnosing the patient, treating the patient. So this was a use case model, one type of interaction model. The next one is a sequence model. So a sequence model, which is also a type of interaction model, but the point here is, in sequence diagram, in sequence model, we depict how the objects are interacting over a period of time. Okay, in a time sequence, at what time sequence, what interaction is happening with respect to the object. So that is demonstrated in sequence model. I'll take the same example so that we can get a bigger picture of how design can be represented using different models, same design. See, we are not deviating on the system or software. It is same one, patient monitoring system for a hospital. Okay, but how different models can represent the design in different ways, that is what we are experiencing here. Okay, now if I am using sequence model, which is a type of interaction model for representing the design. Okay, so how the representation can change, we will see that. Okay, so all the objects we will write here, for example, patient, receptionist, so doctor. Okay, so the vertical line that we are seeing is the time sequence. Okay, so time is progressing in this fashion. So time is progressing in the vertical fashion here. Okay, now in a patient monitoring system, what is the very first thing? First, the patient should check for an appointment, because if doctor is not available and he visiting the hospital will not serve the purpose. So the very first thing is, maybe at a time t1, okay, so patient will send a request to the receptionist, okay, for appointment. So the patient has requested an appointment from the receptionist. So receptionist cannot directly give the appointment. Receptionist should check the availability of the doctor. So during the time the patient wants to visit the hospital. Okay, so what a receptionist will do? Receptionist will forward this request to the doctor. Okay, regarding the availability, whether the doctor is available. Okay, so the doctor will check his schedule. Okay, and after some period he may inform back the receptionist, yes, I am available. Okay, so availability confirmed. So doctor is informing back the receptionist that he is available to check the patient at that time. Okay, so receptionist in turn will confirm back to the patient that yes, doctor is available, his appointment is confirmed. So appointment is confirmed. So receptionist is confirming back to the patient. Okay, see, this is happening at different instances of time, and time is progressing in a sequential fashion. Please note, for example, at the time t1, patient has initiated the appointment booking process. Okay, maybe at a time t2, receptionist has taken this request and forwarded it to the doctor for verification. So at the time t3, doctor has confirmed his availability. At a time t4, patient got back the confirmation about the appointment. Please note the flow of time in a sequential fashion. That is the reason it is called as a sequence model. Okay, from the time the patient has initiated the appointment booking process to the confirmation. So what has happened at different instances of time? At time t1, what has happened? At time t2, what happened? t3. So what was the process that was executed, and in what fashion, in what sequence things have taken place? So a big picture of that will be given using the sequence model. It's a type of interaction. Why it is coming under interaction model? You can see how objects are interacting with one another. For example, you can see how a patient object is interacting with the receptionist object. You can also see how a receptionist object is interacting with the doctor object. So this was the sequence model coming under interaction model. The third one is the activity model. I'll call it as C. So activity model. Now what is activity model? Okay. So once again, it's a dynamic model which is giving the design details of how the system is working from the beginning to the end. From the beginning, I'll call it as start, to the end of any process or activity. For example, a patient visiting the hospital, okay, getting the required diagnosis, treatment, operation, medicines, whatever it is, then billing the patient and discharging him. So from the point where the patient entered the hospital, patient gained entry into the hospital, to the point the patient was discharged. Okay, whatever activities took place. Okay, how the system managed this patient from the point of entry into the hospital to the point where he was billed and discharged. Okay, so if you want to represent these type of design details, so activity model is more suitable. Okay, for example, considering the same example that I have taken now. Okay, so starting point. Okay, now the patient came to the hospital. Please note I am using the same example, that is patient monitoring software or system. Patient came to the hospital, that is the immediate thing that has happened after start of the activity. What are the different, please note we are focusing on the different activities. So patient came, maybe he will be admitted. Okay, once he is admitted, he may be diagnosed. Okay, so he has been diagnosed. Once diagnosed, if it's some serious issues, maybe he may need to be operated. So if it is serious ailments, he may need to be operated. If not, it's not a serious, it's not so serious. Okay, maybe he may be diagnosed in a general ward, given with some medications, and later he may be discharged. Okay, whatever it is, operated or later he may be discharged. Please note, and after discharge it is the end. Okay, so what we can see here, what we can visualize here. So from the starting point to the end, what are the different activities that has occurred in this system considering the patient, okay, interacting with this system in the hospital. Okay, this is the activity model. It's a dynamic model. We can see visualize the different activities handled by the system. Okay, so design details of it can be visualized very easily. So this was the next one, the activity model. So coming under interaction model. Okay, so we completed models in different popular models in OO modeling, object oriented modeling. So next topic is what are the different stages in object oriented development. We will assume that a software company is using object oriented development. What are the different stages? What are the different steps they will follow? Okay, from the starting point to the end point where the software is implemented and deployed. What are the different stages? Okay, the same was briefed already in session 1, where I had given an introduction about object oriented development. Some more detailing will be added in this session. Okay, so what is the major focus here of object oriented development? So the first one is modeling. Okay, we are modeling the concept, not implementing. Okay, already had briefed in the very first session. Module 2 is all about the design aspects of the software. Nowhere we are touching upon the implementation. We are not touching on this. It's only design. Through what? Modeling. Okay, now what concepts you are modeling? For example, if it is a patient monitoring software, okay, so what are the different entities that are related to this system? For example, doctor, patient, how a typical process occurs, how a patient may visit a hospital, what procedures are there, what formalities are required. If it is a library management software, who are the stakeholders, what is a typical procedure that is followed when a book is borrowed from a library. So all these things conceptually the designers will try to understand how things are working. See, a student visiting a library and borrowing a book, okay, the conceptualization is different from a patient visiting a hospital and getting the diagnosis. Okay, it's completely different. So this conceptualization will be done in the very first stage. Okay, please note, we are not into any implementation or programming, so that is a major emphasis here. Okay, so once a conceptual framework is developed, the next step, the next stage is analysis. So rigorous interaction with the client will be done here to understand how the system is working or how the system should work. Because for example, typically you are developing a software for a library, so how the library system works. So the designers should first try to understand that in interaction with the stakeholder. Okay, so in the library different stakeholders will be there. For example, librarian, the staff who are managing the different compartments. If it is a hospital management software, various stakeholders are there, like a doctor, nurse, a receptionist, management. Okay, so with all the stakeholders, interaction will be done and a conceptual framework will be developed where the designers will try to understand how the system is working or how it should work. Once done with it, the next part is the analysis part. So what is happening in the analysis part? Okay, so in analysis, the basic modeling will start here. Okay, modeling will be developed, and basically two types of modeling will be developed during analysis. The first one is what we call as a domain model. Okay, so what is a domain model? So domain model is a description of entities or objects that are there in that system that needs to be developed. Okay, for example, if it is a patient monitoring software, okay, what are the different real world entities? Already we have seen it. It may be a doctor, a patient, nurse. If it is a library management software, I'm writing the short forms just to save time. So LMS, library management software. What are the different entities? What are the different real world objects? Okay. So librarian, students. Please note, the domain model depends on the software or system we are developing, and the real world objects may change, will change. Okay. So this is domain modeling, where the analyst will try to understand what are the objects, real world objects related to the system. The second one is the application model. So application model. So what is a application model? So application model, the analyst will try to understand how each and every real world object or entity will interact with the system. What interfaces should be given to them. Okay. What parts of the system should be visible to them. What should not be visible. So all those things will be decided upon by the application model. So I'll give you an example. For example, consider it as a patient monitoring software. Okay. And in application model, the analyst wants to design the parts of the system that should be visible to the patient and the parts of the system that should not be visible, that should not be accessible to the patient. So if that is the case, what are the parts of the system, or what are the parts of the application that should be accessible to the patient in the patient monitoring software or the hospital monitoring software? Maybe in the application, the book appointment. See, this should be visible to the patient. This should be accessible, because a patient should book an appointment before he is visiting the doctor or the hospital. So this part of the system should be accessible. Okay. So a patient, should he be given access to details of the doctor? All the details of the doctor. Should he be given access to all the details of the doctor? No, definitely not. For example, doctor name. Yes, let us give access of the name of the doctor. Doctor specialization. Yes, because based on this, maybe the patient may decide whether to visit this specific doctor or not. PAN card of the doctor. Now, is this a detail required for the patient? Definitely not. Okay. So how and where all these things are being decided? Like which part of the system, which part of the application should be given access, which part of the application should not be given access to the real world objects that have been identified in the domain model, where it is decided. So it is decided in the application model. Which parts of the system should be accessible, which part of the system should not be accessible. Please note, all these things are decided or planned. The planning of this is done in the design stage itself during over development. See, please note, we are not planning this during implementation. Implementation is just a realization of this plan. That's it. Okay. So complete planning is done during the object oriented modeling. So this is the second step, and once done with analysis, we enter into the third one. So the third one is called as the system design. Okay, so in system design, what exactly we are doing? So in system design, we plan the architecture of the system. Okay, overall architecture, the big picture of the system. Like if this rectangular box is my system, for example the patient monitoring software, what are the different subsystems under this system? Okay, for example system 2, system 3. This is just for representation explanation purpose, it need not be like this. Okay. Our patient monitoring software is having these systems. A system can even have a subsystem. For example, this system is having subsystems, subsystem 1, subsystem 2. Okay. So what are the different systems? What are the different subsystems? How maybe they are interacting with one another, how they are dependent on one another, how they are communicating with one another. Okay. What input is being given by one system to another system, what output is being taken. Okay. A big picture of this, a complete overview of it represented as what we call as an architecture of the system, and that comes under system design. Okay. Also, not limited to this, we also plan of the resources, what resources to be allocated for designing and developing this. Okay. Resource allocation will be done. So with resource allocation, we even decide on the performance, how a system, what performance is being expected from different parts of the system. Okay. What type of requirement, and what requirement should come out with what type of performance. So all these things are decided here. And as already mentioned, how it should communicate with one another. So communication. So all these things are decided in this part, that is the design part, the third one. So once you are clear with the design, next you will come out with the class design. So this was system design. The third one. The fourth one is class. Okay. So we try to identify classes that can be realized from these systems. For example, system 2 is completely dealing with doctors. Okay. We'll assume like that. So maybe we will come out with one main class called as class doctor. Okay. One main class, class doctor. Under this main class, we can have many subclasses like a doctor who is with orthopedic specialization. Okay, he is a different subclass. A doctor who is dealing with gynecology. Okay, a doctor maybe in ENT. Different specializations. Okay. So how these subsystems are interacted, how they are related. So design of details of it represented using a class design. Okay. That is the fourth one. And once we are completed with this, so we have come down to the fine grain level of the design. Please note, we have identified the entities, we have built the overall architecture, we have planned the different classes for the different systems and subsystems in the software, how they should interact, what are the requirements, what are the resources, everything has been meticulously planned. And once done with this, next we can enter into the next stage, that is implementation. Okay, so what is implementation? So hard coding. So whatever plans you have in the design, whatever blueprint you have created, so start creating the code for it, start building the functions, APIs for it. Okay, so that is implementation. And we use obviously software engineering practices for it. Implementation details we will see in module 3, so we will not touch upon this in this class. So in session 3, a brief recap of what was discussed in session 3. So we rebrushed, we had a recap of what we saw in session 1 and 2. So I'll just summarize session 3. So we had a recap of session 1 and 2. The reason is session 3 is not completely different. It's a continuation of what we had understood in session 1 and 2. So once done with it, we started with the object oriented themes, the major themes of object oriented design modeling. So we understood what is abstraction, we understood encapsulation. So once we completed with this, we understood the three modeling techniques, the three popular ways of modeling. Okay, modeling using object oriented design. The first one was the class model, which was a static model. The second one was the state interaction model, state model. The third one was the interaction model. Okay. So finally, we concluded session 3 with object oriented development. We understood how object oriented development is taking a transition from the starting point to the implementation level. Okay, how different things are going in sequence, we understood. So it all started with conceptualization. Then the analyst is deciding on the domain and application requirements. Once done with this, he will come out with the architecture of the system. Once the architecture of the system is finalized, a class model is created. Once done with the class model, so then he will, then we take a transition into the implementation. Okay. So this is what we saw in this session, session 3. In session 4, so we'll see few more aspects of object-oriented modeling, where we will try to explore all these aspects in much more depth and detail with added information. Okay, so thank you.